In this video, we will talk about introduction to static and variable loads, their types, and their applications for failure prevention in mechanical engineering design. After attending this lecture, you will be able to define and understand static load. You will able to define and understand variable load. You will be able to identify and understand various types of static loads, and similarly you will be able to know the effects of variable loads. These all outcomes will be with reference to design of machine elements. For a load to be static, the force or couple applied as a load must be unchanging in magnitude. So if you talk about the magnitude of this force, that should remain constant. So for example, if this is a couple applied at point A and this wrench is turning this nut, then this force or couple should remain unchanged. Similarly, this force, if it is at a point, the point of application of this force must also be unchanged. So the magnitude or quantity and the point of applications, if remain unchanged, it's static load. And there's another type of static load that the direction of this load should also be remain the same. So the direction, quantity, and points of application remain unchanged, then that type of load is called static load. So basically, there is no change with respect to time. So now we want to know what are the types of static loads. So first type of static load is axial. So in this case, if you see this cylinder, these three cylinders, if it is not loaded by any force, it is known as unloaded. But if there is a load applied, a force applied along the axis of this element, this type of load is known as axial load. Remember that axis of a structural member is normally the force along that direction which is larger than the rest of dimensions. For say this cylinder, the largest dimension of this cylinder is the length of this cylinder. The radius is very small as compared to the length. So the axis of this element is the length of this element. So if a force is applied at the centroid of this cylinder, then this is an axial load. Axial forces, axial loads can be further divided into two. The first one is the tensile force or the tension load. This load tries to pull this away and it tries to elongate the length of this cylinder. The second one is compression. Compression tries to reduce the length of this cylinder that is pointing inwards. So this type of force is called compressive load, or the load is called in compression. So this member is in tension, this member is in compression, and both are known as the axial loads. The next one is the shear load. So shear load is this figure here. So if the force applied is not in the axial direction, rather it is perpendicular to the axial direction, and it tries to break or shear this element, this is known as the shear load. So this element is known to be under shear load. So, and this force is not along the axis of this member. The effect of this shear load is that if this shear load exceeds a limit, this cylinder will break into two pieces. The third type of loading is the bending load. So this figure here is telling this cylinder is being bended. So if the forces try to apply a moment in such a way that this element takes the shape of a cup from one side and it becomes convex from the other side. This is known as a bending load. Bending load is again not along the axis, and also it is not perpendicular to the member in such a way that it is not causing the machine element to break. It is causing the element to bend. So this is known as the bending load. Another type of static load is torsional load. This is example of torsion. So if a load tries to twist a machine element, it is known as a torsional load. So this tries to turn or twist this cylinder, and as a result, if the twist is exceeding some limit, this will take a twisted shape under torsion. So this type of load, which has a turning effect because of the torque, this is known as torsional load. The last one is the combined loading. So if we have a combination of the first four, any two of these, we call it combined loading. So as an effect of the combined loading, there will be the twisting load, the tensile or compressive loading, and also the bending load and the shear load. So all these combined loading will have an effective shape of the mechanism under loading, and this can cause the failure in that mechanism. In this case, we try to see which load has the more effect than the others, and then we think that this mechanism will be, or this machine element will be failing because of that load. Sometimes some combined loading effects try to have a constructive effect of the element, and the element breaks or fails before the anticipated load. So if I try to give examples of all this, for the tension or compression, consider a rubber, and if you rubber or elastic string, if you try to pull it, its length is increased because of the tensile load. If you try to push it, its length is decreased because of the compressive. And if you have some wire in your hand and you bend it, the force tries acting as for the bending of this element will be known as the bending load, and that wire will be bended. If you want to see the shear effect, if you hold a long toffee in your hand and if you apply a force in this direction, it will be broken into two pieces, and if you twist that toffee, it will have a twisted shape, and that would be the torsional load. So all these loads will be studied when we are studying the failure of a machine element under static load. The next one is a variable load. A variable load is a load which is changing with time in magnitude, in points or point of application, and in direction. So if in this example, if this magnitude of this force or couple is changed, let's say it in the beginning it is 10 Newton at time 0, and at time 1 it is changed to 20 Newton, then it will not be a static load anymore. It will be known as a variable load. Also, if we apply it sometimes at this point, sometimes at this point, sometimes at this point, then we will again call it variable load because of the changed point of application at different times. Thirdly, if we change the direction of this applied force, let's say at time 0 it is in the downward direction, at time 1 it is in the upward direction, again we will call it as a variable load. So for the variable load to be variable, one of these, at least one of these things must be changing with time. Okay, so when the load is variable, we also have to take in consideration the time of application. So that's the definition of variable load. So in the variable load, when you apply the force in a changing magnitude, point of application, or direction, what happens is that there is fluctuation of forces. So because of these fluctuations, we say that there are force per unit area which is variable. or which is repeated after some time, or which is fluctuating, or which is alternating. So there will be forces if we have large number of time with us that they are changing. So because of these changing forces, we will have a variable, repeated, fluctuating, or alternating stresses. Stresses are nothing but the force per unit corresponding area. So these stresses will be changing. So such stresses, if are repeated for very large number of times, we call them fatigue forces. And if the machine element is failed, is broken, or is distorted, or whatever the failure mode or shape it is having, if it is because of large number of changing repetitive loads or stresses, we call this failure as fatigue failure. So now you know that what is a variable load and what is a static load. So practically when we have designed mechanical systems or machine elements, what do you think? Which type of loads mostly cause failures? The static loads or the variable loads?